Hi everyone, today we're going to be looking at a problem that has to do with free fall. It's a really important topic in Physics 1 in general. So let's get into it and read the question. A ball is thrown up at t equals 0 with an initial speed of 19.6 meters per second from the top of a bridge. So before continuing, you might want to draw a diagram because drawing diagram always helps you understand the problem more and it helps you visualize your axis and your origin and everything, which will ensure that you don't mess up when it comes to signs and numbers and all of that. So here's the water and it's from the top of a bridge. Okay, let's assume this is the bridge. And someone is standing on top of this bridge and is throwing a ball upwards with an initial speed of 19.6 meters per second. It takes 5 seconds to hit the water under it. So T final, or the time it takes to reach the water, is 5 seconds. You have to keep in mind two very important things. You have to draw an axis for yourself. So over here, I'm assuming that my y-axis is pointing up, but feel free, you can, point it downwards. Then your gravity is going to be positive and your values are going to be positive. But I prefer having the traditional upwards y-axis. And you have to have an origin. So I'm gonna start basically, the origin is where you start looking or studying the motion of the object that's in the question. So I'm gonna have it at the point where it's thrown. So this is my origin. That way, your initial value for position will be 0. So it's just less numbers to deal with, but you can feel free to place your origin and axis in any direction and anywhere. It could be under the bridge, it could be near the water, it could be at the very top. It's really up to you, but you have to be very careful when looking at the numbers. So over here, since my y-axis is upwards and this ball is being thrown upwards, then my velocity is going to be positive. It's very important to note. So the first part asks, what was the height that the ball was thrown from? So we want to find this y. So from your kinematics equations, you know that y final is half at squared plus v initial t plus y initial. In this case, if you notice, I talked about the origin, which is over here. So the ball was actually at 0, so I can get rid of this term. Y final is what I'm trying to find. This object is in free fall, meaning that the only force that's causing motion over here is gravity. And gravity's acceleration is known, it's 9.8 meters per second squared. However, since my axis is up, I can't forget my negative sign. So that's minus 9.8. My time was mentioned in the question, which is 5 seconds. So I'm going to substitute my t with 5 squared plus v initial, which was also given, and it is positive because it's upwards. Had it been downwards, it would have been a negative velocity, 19.6 times the time once again, which is 5. After that, you simply substitute in your calculator. You will notice that you're going to get a negative value, and that's because of one reason. My axis is pointing upwards, so everything I'm calculating over here is below 0. So this is your negative y final. So basically your y final is just the positive form of this value, which is 24.5 meters. This is why I'm saying it's really important to choose your origin, and everything has to be with respect to that reference point or origin. So this is the answer to part A. Part B asks, how long does it take to reach the highest point? Referring to the ball, obviously. So over here, at the highest point in free fall, we know that the velocity is 0. And so we have this kinematic equation that is v final equals at plus v initial. So at is acceleration times time plus the initial velocity. We want to set v final equals 0 because we want to find the time at the highest point, which is when the final velocity is 0. So the acceleration remains constant in free fall. It's still negative 9.8. And the time is what we're trying to find, plus the initial speed given in the problem, which is 19.6. Once you calculate this, you will get the time as minus 19.6 divided by minus 9.8, which is exactly 2.0 seconds. So this is how long the ball takes to reach the highest point of its flight, like let's say over here. Part C asks you what is the ball's velocity when it reaches the water or when it hits the water. Over here, we're actually going to use the same exact equation as in the previous part, except the only difference is going to be the time. The time, we will use the final time that is given in the question and how long basically it took to reach the water. So V final is still the same acceleration. This is why free fall is very convenient. The time was 5 seconds and the initial velocity was 19.6, which are all given values. So you will get your final velocity as negative 29.4 meters per second. Don't forget the units, don't forget the signs, and everything aligns perfectly because right now it's going down, which is opposing the direction of our axis, which is why the velocity is actually negative. So I hope this helps. Feel free to comment any questions and suggest problems for future videos.